Okay, so I made this little sketchpad sketch, and if you want, you can download it in the description below. But I made it to show you a little property of the trapezoid, the area of a trapezoid, the formula for the area of the trapezoid that maybe you didn't realize before. And I think it kind of makes me endear myself to that formula just a little bit more. Now, basically, I'm going to show you that a parallelogram, a rhombus, a rectangle, a square, and a triangle are all different special cases of a trapezoid, and thus you can use the formula for area of a trapezoid to calculate their area. What I'm not going to be trying to convince you of is that using the trapezoid formula for these areas is the most efficient way to get them. I just think it's a kind of a neat property of a trapezoid. So let's start with a parallelogram. Well, let's start with the sketch, actually. So the sketch is dynamic, so you can actually change the sides, and it recalculates for your particular trapezoid what the area is in each case. So you can do that, and it recalculates that in real time. If we turn this trapezoid into a parallelogram, you can see that here are all the measurements, same measurements there for that parallelogram. They plug into the trapezoid formula, and they also plug into the area formula for parallelogram, and you get the same areas in that case. And we would expect that to be the case because it's the same shape. And it doesn't matter whether you're talking about the area of a parallelogram or a rhombus. Since a rhombus is a special case of a parallelogram, we would expect that if you use this A, this H, this B in the trapezoid formula, we should get the same area as if we were just to use the parallelogram area formula, and we do. So a parallelogram or rhombus are both special cases of trapezoids. Now, a rectangle should also be a special case of a trapezoid. It has two parallel sides. And so if we turn this trapezoid into a rectangle, then we get the height is 6, the top side is 11, the bottom side is 11, and by using different labels, the length is 11 and the width is 11, and plugging into the formula, we get 66 and 66 in that case. So the rectangle is a special case of a trapezoid. It's also a special case of a parallelogram. And by that extension, the square is a special case of the rectangle, and thus the formula for a square, which of course is the simpler way to calculate it, we can also use the formula for the area of a trapezoid and get the same answer. So again, square is a special case of a trapezoid. Now my favorite one is the triangle. And the triangle isn't obvious at first, I don't think, that it's a trapezoid, but in fact it is. In fact, if we take that top length and bring it down to 0, that trapezoid becomes a triangle. And if we use 0 for that top length in our formula, then the formula works just like the area of a triangle formula, and we get the same area. So again, just a neat property of the formula for area of a trapezoid. I'm not trying to convince you that it's the best formula to use. I just think it's kind of neat that you can use it in so many places.